as we discuss what we consider systemic circulation, it's very important to discuss blood flow. What is blood flow? Blood flow is the amount of blood in that entire circulatory system there, all right, within a certain amount of time. Typically, that time is in a minute, all right? So we're already right there. It sounds familiar, right? With regards to the heart, we had something that was very similar. It was the amount of blood that was ejected from the ventricle, from your ventricles, in a certain amount of time, right? And so that was cardiac output. So we have something that's very interesting here. These two are very similar. Very similar. You have a cardiac output which ejects blood within a minute from ventricles to the actual systemic circulation from the heart, right? So that's what ends up being the entire amount of blood, all right, in your systemic circulation within a minute, right? So pretty much they're the same thing. It's just that cardiac output is this factor as it relates to the heart and what the heart is doing, right? And blood flow is in reference to the blood that's in the systemic circulation, the vascular portion. So heart, vascular, but they're basically the same thing. And so later I'll show how we put those guys together, right? But let's just focus on blood flow here. Of that amount of blood within your entire systemic circulation, right, within a minute, and how there are factors that actually will influence that. All right. So let's point out the fact that blood flow is fairly easy. It's just like your flow of traffic on Interstate 95, right? And so that's what that is representative of. It's basically that flow of blood that's getting to tissue. And so it can change, just like the Interstate 95 traffic can change, right? Depending on if you're in rush hour or not, right? So let's look at the factors that contribute to that, and then we can visualize that same experience we've had on Interstate 95, right? So let's look at this factor, which is directly proportional to the flow, which is mean arterial pressure. The average amount of arterial pressure, okay, in your actual systemic circulation. If we look again at our systemic circulation, we'll see that wherever the source of the pressure is, the closer you are to that source, and who's creating pressure in this system? The heart. Whatever's closest to it has the highest amount of pressure, right? So a definitely beginning portion of our entire process here, which is the aorta, has the most pressure, right? As you go farther away from the source, pressure decreases even more, and really small, right? We don't really say anything about venous pressure because it's very, very, very small. Yes, there is some pressure there. There's pressure along your venous portion here of the systemic circulation, and hardly any pressure once you get to the right atrium, right? Because that's the farthest away from where? The source, right? As far as the left ventricle, the left side of the heart. So therefore, we don't really consider the actual venous portion as much. What we do is we take an average of the pressures throughout the entire arterial portion, all right? And we take that average and say that's the mean arterial pressure. That's that pressure, basically, that's pushing blood to tissue. And how important is that? Very important. Okay, that's the means by which you have oxygen and nutrients getting to tissue. All right, so pressure isn't bad. High blood pressure is bad. Okay, because if it's too much pressure on delicate tissue, then it will damage that tissue. All right, but pressure in general, a good within normal limits pressure, is going to distribute oxygen and nutrients to the tissue. And oxygen and nutrients has to get to cells so that cells can live. Right? So we need pressure. Right? One of the major things we check first with a patient unresponsive. as it relates to whether they are unresponsive because they don't have oxygen and nutrients to tissue. All right, so one of the first things we check, pressure, blood pressure. All right, so that's very important, and definitely blood pressure is going to dictate that flow of traffic, right? That blood flow, that amount of blood in that entire systemic circulation getting to tissue. All right, it is directly proportional. If you increase blood pressure, you increase your flow of traffic, right? So you decrease blood pressure, then you decrease that amount of flow. Very, very simple. Okay, what's not simple, what's not that easy, right, is actually what we consider any sort of force that's against the flow, right? And by definition, that's what we consider peripheral resistance. Right? So peripheral resistance, it does not have a directly proportional relationship. It has an inversely proportional relationship. All right? And I'm speaking in mathematical language because that's as simple as it is, right? Directly proportional, like we saw with our actual cardiac output equation, means that if you increase heart rate, you increase cardiac output, you increase stroke volume, you increase cardiac output, directly proportional, right? Whatever increases on that one factor, that's going to cause the other feature of that equation to increase, right? So with your inversely proportional relationship, it's the opposite. If you increase peripheral resistance, then you decrease blood flow. If you decrease peripheral resistance, then you increase blood flow. All right, so keep rehearsing that. All right, rewind that if you want again. Understand that that's all you have to do. Just remember that feature there. Yeah, as far as the relationship between peripheral resistance and blood flow. All right, but let's just break down peripheral resistance a little bit more so that we can clearly understand what these forces are, what forces are involved as it relates to going against blood flow. And so basically what the equation of peripheral resistance is basically the length of your actual vessels times your viscosity of the blood there that's in those vessels, right? What does viscosity mean? Thickness, right? Obviously are definitely going to be directly proportional to peripheral resistance, right? You increase the length of this system, well, that's more that you have to go through to get to your destination, right? So that's definitely a force against flow, right? And also the thickness of that. Like if you have a lot of congestion on Interstate 95, right? It's very congested on Interstate 95, then definitely that goes against what? The flow of that traffic, right? So therefore, yes, viscosity, increasing viscosity increases that resistance, right? Directly proportional actual factors there, all right? But those don't change. Those factors don't change. You have your typical length of your systemic circulation depending on what individual you are. And then your blood viscosity pretty much stays the same. It's a constant thing, right? So what we're really focusing on is this other factor, which is the actual vessel radius, right? The radius of the actual vessel. What specific vessel? Arterioles, okay? And so, and that's why is the arteriole so special? Like I mentioned before, because its walls are basically just smooth muscle, right? And so that's what's going to change things as it relates to blood flow. That's what's going to change things as it relates to pressure. And it's that arteriole, the walls of the arteriole that have this smooth muscle that changes a lot of things, okay? So that's what we're going to peek at, look at, and we're going to understand how your actual vessel radius of arterioles, don't forget we're talking about arterioles here, how that vessel radius changes your pressure, all right? So we'll talk about